Proxima B, the exoplanet orbiting the nearest star to our solar system, has long fascinated both scientists and dreamers alike. While much of the attention has been focused on its sunlit side, the planet's dark side, perpetually shrouded in shadow, has remained a mysterious unknown. However, the James Webb Space Telescope has now unveiled intriguing data that shed light on this hidden region, revealing surprising findings that have left experts both astounded and puzzled. One side of Proxima B is constantly exposed to sunlight, while the other remains locked in unyielding darkness. Previously, it was believed that the dark side was inhospitable and barren. Yet recent declassified images have begun to tell a story no one anticipated. The first clues emerged in the form of unusual emissions detected from the dark side of Proxima B. These faint but consistent signals challenge conventional ideas about planetary environments. Infrared radiation and unique energy signatures point to localized sources of heat and light phenomena that don't align with the planet's established conditions. Could these emissions be naturally occurring, or do they hint at something far more extraordinary? The strange structure and variability of these signals have prompted some scientists to entertain the possibility that they may have artificial origins. Could it be that the dark side of Proxima B is concealing advanced technological activity? If these emissions are indeed artificial, they could suggest the presence of civilization thriving under extreme conditions. Advanced technologies might be in place, generating light and warmth to overcome the challenges posed by the planet's eternal darkness. These emissions, resembling urban lighting, imply organized activity. Could this point to a society that has adapted to and is flourishing in an environment devoid of natural light, thriving in ways beyond our current comprehension? The implications of these findings are enormous. If life exists on Proxima B, it might have developed technologies far more advanced than anything we can currently imagine. These technologies could enable survival in one of the most extreme environments in our galaxy. Proxima B's unique characteristics, perpetual sunlight on one side and unending darkness on the other, create a planet of stark extremes. Temperatures on the dark side could drop to levels that make life, as we understand it, impossible. Without a substantial atmosphere to distribute heat, any form of habitation would likely rely on artificial energy sources. Could a civilization on the dark side have solved this problem by developing systems to transport heat and power into the shadowed areas? Achieving such a feat would require engineering expertise far beyond anything we have on Earth, offering valuable insights into how advanced life might function. One of the most remarkable findings was the potential presence of water on Proxima B's dark side. While liquid water on the surface may be improbable, there could be subsurface reservoirs sheltered from the harsh environment. Water is essential for life as we know it. So if it exists here, it suggests the possibility of extremophiles life forms that thrive in the most hostile conditions. The discovery of water would not only expand our understanding of habitability, but could also provide a glimpse into how life might adapt to survive in one of the universe's harshest environments. Despite the groundbreaking nature of these revelations, the data raise more questions than they answer. Is the source of these mysterious emissions, are they the result of natural processes, or do they indicate something far more significant? The recurring patterns of these emissions imply intentionality, yet no known natural process fully accounts for them. As researchers continue to analyze the data, one thing is clear: the dark side of Proxima B is not the lifeless void we once thought it to be. Instead, it is a place brimming with mystery, potential, and unprecedented discoveries. The emissions detected from Proxima B's dark side prompt an intriguing question. What is powering them in an environment devoid of sunlight? Traditional sources of heat, such as solar power, seem unlikely. One theory proposes that the planet's core could be geologically active, generating geothermal energy. This heat might sustain subsurface water reservoirs and power systems on the dark side. Another theory points to the possibility of nuclear energy, an energy source capable of generating immense power in isolated, lightless conditions. If the emissions are artificial, They could represent the work of a civilization that has mastered these forms of energy generation. Whether the emissions are natural or artificial, the energy source behind them could radically alter our understanding of power generation in extreme environments. Further analysis of Proxima B's dark side revealed unexpected patterns in its thin atmosphere, or what's left of it. Trace amounts of gases, including carbon dioxide and methane, were detected, raising questions about their origins. The detection of methane, in particular, has sparked debates among scientists, with some considering the possibility that it could be a byproduct of microbial life or something entirely unknown. The uneven distribution of these gases suggests localized sources, possibly linked to the mysterious emissions. Could this be a clue pointing to active processes or even life on Proxima B's dark side? Proxima B is just one of many exoplanets observed by the James Webb Space Telescope, yet its dark side stands out as a particularly enigmatic case. By comparing it to other tidally locked worlds, scientists hope to identify patterns that might explain its unusual characteristics. While most tidally locked planets exhibit extreme temperature gradients, the emissions and atmospheric anomalies observed on Proxima B's dark side make an outlier. These findings suggest that Proxima B may harbor processes unlike any we've observed elsewhere in the universe. As we learn more about Proxima B, our assumptions about exoplanets and their potential for habitability are being challenged. One of the most contentious theories surrounding the dark side of Proxima B is the possibility of advanced technology. The structured patterns of the emissions, coupled with the energy demands required to sustain them, strongly imply the involvement of intelligent forces. Could these emissions be the product of an extraterrestrial civilization? If so, their technology would be far beyond anything humanity has ever conceived, capable of thriving in an environment of perpetual darkness. While this hypothesis remains speculative, it raises profound about how life and technology could evolve under conditions drastically different from our own. The discoveries from Proxima B's dark side have reignited interest in interstellar exploration. Although sending a spacecraft to the planet would be a monumental challenge, the potential rewards make it worth pursuing. Organizations like Breakthrough Initiatives are already investigating ways to reach Proxima Centauri within a human lifetime. The data collected by the James Webb Space Telescope provide a roadmap for future missions that will focus on Proxima B's dark side. These missions could help answer the many questions left by Webb's observations, from the source of the emissions to the nature of the structures hidden in the planet's darkness. The possibility of technology or even life on Proxima B challenges us to rethink our assumptions about what is possible. It sparks curiosity, offers hope, and perhaps even a touch of fear, as it reminds us of the vastness of what we have yet to learn about the universe.